Welcome to Everyday Explained, your daily 20-minute dive into the fascinating hows and whys of the world around you. I'm your host, Chris, and I'm excited to help you discover something new. Let's get started.
Every single night, you close your eyes, drift off, and boom, you're in this completely different world. Sometimes it's weird, sometimes amazing, maybe a bit scary, but it's always, well, yours. We're talking about dreams, of course.
It's something everyone does, but it still feels so mysterious, doesn't it?
Totally. And you, our listener, really wanted to get into the nuts and bolts. Like, how does it even work? What's happening in your head? And yeah, what about that dream where you're flying a washing machine? One of our sources actually used that example. What could that possibly mean?
Right. It's this incredibly vivid story playing out, feels totally real, and then, poof, maybe gone the second you wake up.
Exactly.
And the sources you pulled together for us today are really fascinating. We've got brain science, psychology theories, even some, super cutting-edge stuff that sounds wild.
It really does. So that's our mission for this deep dive. Unpack all of that. We're going to look at what the science says is happening in your brain, the actual mechanics.
Yeah, the sleep stages, the brain activity, the chemicals involved.
Right. And then tackle the big questions. Why do we even dream? What do the experts think about common dreams?
Yeah.
And what they might signify, or maybe what they don't signify.
And we definitely have to talk about that new research, the stuff that honestly feels like it's straight out of science fiction.
Oh, absolutely. We'll be drawing from research highlighted by places like the National Science Foundation, Psychology Today, Frontiers for Young Minds, trying to give you the essential takeaways from all of them.
Distilling it down, yeah. Giving you that informed picture without you having to read, stacks of papers.
Okay, let's jump right in then. To really get dreaming, you first got to understand sleep itself. It's not just off.
No, not at all. It's a cycle. Your brain goes through these really distinct phases.
Right. You start with NREM sleep.
Yeah.
Non-rapid eye movement.
Exactly. Stage 1 is super light, that drifting off feeling, maybe just a few minutes.
Where you might twitch or feel like you're falling for a second.
Precisely that. Then you slide into stage 2 NREM. Still pretty light, but it's actually where you spend about half your total sleep time. Heart rate slows, temperature drops. You're settling in.
And then comes the really deep stuff. Stage 3 NREM.
Correct. Sometimes called slow wave sleep. This stage is physically restorative, really important. And it's heavily involved in consolidating certain types of memories like facts, events, things you learned.
So while you're deeply out of it, your brain is busy filing away the day's data. But where do the big story-like dreams usually happen?
That's primarily during REM sleep, rapid eye movement sleep. Sometimes called stage 4, though technically it's distinct.
Yeah.
This is where things get, really active.
Active how?
Surprisingly active. The key thing is your brain activity during REM. It looks remarkably similar to when you're wide awake and alert. Fast brain waves, breathing, and heart rate pickup.
Wait, seriously. My brain's running like it's awake, but I'm asleep.
Pretty much. But here's the paradox. While your brain is firing on all cylinders, your major voluntary muscles are almost completely paralyzed.
Whoa, why?
Well, the thinking is, it's a safety mechanism. It stops you from physically acting out your dreams. Imagine running from a monster in your dream and actually running into your bedroom wall.
Okay, yeah, good point. Paralysis is probably helpful there. So the only thing moving is your eyes, darting around.
Exactly. That's the rapid eye movement. You can sometimes see it if you watch someone sleeping. But it's important to say, while REM is famous for vivid dreams, you can have some mental activity, some dreamlike thoughts in NREM stages too. They just tend to be less cinematic, less emotional.
Got it. Less likely to involve flying washing machines.
Probably less likely, yeah.
Okay, let's zoom in on the brain during REM sleep then. What parts are lighting up, or maybe crucially powering down, to create these bizarre experiences?
Okay, a couple of key players. The thalamus is really busy. Think of it like a relay station in your brain.
Okay.
It's sending sensory information sites, sounds, feelings up to the cerebral cortex, the brain's big processing center. This helps create those really vivid, lifelike sensations in dreams.
So the thalamus is like the projectionist running the dream movie.
That's a good way to put it. But here's a really interesting bit, something one source highlighted to explain the sheer weirdness of dreams. The prefrontal cortex is less active during REM.
The prefrontal cortex, that's the sensible part, right? Logic, planning, decision-making. Our internal editor.
That's the one. The executive control center. Its reduced activity is a leading idea for why dreams can be so illogical, so disconnected, frankly, so bizarre. The part of your brain that would normally go, hang on, that doesn't make any sense, is kind of offline.
Okay, that explains a lot. My inner logic checker is taking a nap during REM.
Seems like it. And it's not just brain regions, it's also about the chemicals, the neurotransmitters. They create a unique cocktail. Acetylcholine, for example, is really high during REM. It's linked to learning and memory, and it's thought to really boost the vividness of dreams.
It makes the dream feel more real, more intense.
Could be, yeah. And dopamine, the reward chemical that's involved too. Sources suggest it might influence how vivid dreams are and maybe even how intense nightmares feel.
So strong dream emotions might have a dopamine link. Interesting.
It's possible. And on the flip side, other chemicals like serotonin and norepinephrine, which keep you alert and focused when you're awake, their levels drop way down during a REM.
So turning down the focus chemicals lets the imagination run wild.
That's the thinking. This chemical shift likely contributes to that free-flowing, uninhibited, sometimes totally off-the-wall nature of dreams.
It really sounds like a very specific, carefully balanced state.
Yeah.
Active mind, still body, weird chemical mix.
Yeah.
All to create this nightly theater.
Which brings us to the huge question. Why? Why do we even do this? What's the point of dreaming?
And that's where, the sources are very clear. There's no single answer everyone agrees on. Not yet, anyway. What we have are several major theories, each with some evidence suggesting dreams might do a few different jobs.
Okay, lay them on us. Maybe start with the classic one, Freud. Right, Freud's psychodynamic theory. He proposed dreams are basically wish fulfillment, a way for our unconscious minds to express hidden desires, repressed thoughts, maybe work through conflicts we can't face when we're awake.
The idea of hidden meanings and symbols.
Exactly. Though we'll circle back to how current science views that specific idea. More modern cognitive theories see dreaming differently. The cognitive theory, for instance, suggests dreaming is just thinking, but in a different biochemical state. Your brain is still processing information from your day, maybe working on problems, consolidating memories, dealing with emotions.
Like your brain is running background tasks while you sleep, defragmenting the hard drive maybe.
Something like that. Related is the memory consolidation theory. This one specifically argues that dreams play a key role in organizing and storing memories, integrating new stuff with old stuff. And REM sleep might replay events, and then REM sleep might sort of shake things up, link things in new ways, help learning stick.
So the weirdness of REM dreams might actually be part of making new connections, creative memory linking.
That's one way to look at it, yeah. Then there's a more bottom-up idea, the activation synthesis model. Hobson and McCarley proposed this. It suggests that during REM, there's a lot of somewhat random neural firing happening in the brainstem. The higher brain tries to make sense of this random activity, weaving it into a story.
So the dream narrative is just the brain trying to find a plot for random signals. My flying washing machine is just noise interpreted as flight.
According to that model, yes. The story is the brain's best attempt to synthesize chaotic input into something coherent, even if it's bizarre. Then, shifting focus, there's the threat simulation theory.
Sounds intense.
It suggests dreaming evolved as a kind of virtual reality simulator for danger. By practicing escaping threats or dealing with scary situations in a dream, you hone your responses, improving your chances if you face similar threats in real life.
Like a mental fire drill.
Kind of, yeah. An evolutionary advantage. And finally, there's the emotional regulation theory. This focuses on how dreams help us process and manage our feelings. Especially with the amygdala, the emotion center, being active in REM, dreaming might let us re-experience emotional events and sort of work through them, find balance.
Wow, okay. So it's not just one thing. Dreams could be involved in memory, emotion, creativity, problem solving, maybe even survival skills. It sounds like they're doing really complex, important work.
That's the picture emerging from these different perspectives. It's definitely not just random nonsense, even if the content feels that way sometimes.
Which perfectly leads to the question you asked about, specifically the one everyone asks, what does it mean? When you dream you're being chased or you're falling or suddenly back in high school taking a test you didn't study for.
Right, and studies confirm these are super common themes: being chased, falling, school stuff, flying, sex, trying and failing to do something, even seeing loved ones who've passed away. Those pop up a lot across cultures.
Okay, so common themes exist. Does that mean there's like a universal dream dictionary? Falling always means insecurity. Teeth falling out always means anxiety.
This is where the sources we looked at get really, really interesting and maybe challenge some popular ideas.
House?
While everyone agrees that dream content often reflects what's going on in your waking life, like if you're stressed about work, you might dream about work problems. Oh, it makes sense.
Sure.
But the idea of a fixed universal symbol code, The sources are pretty blunt about that.
Blunt how? Give it to me straight.
Okay. One source we consulted uses very direct language. It basically says the idea that there's a common code book for dreams or that you need some expert interpreter to unlock a hidden meaning is, and I'm quoting the sentiment here, bullshit.
Wow. Okay. That's direct.
It stated there's no evidence for that kind of hidden manual, no secret key.
So my flying washing machine dream doesn't have a pre-written meaning in some ancient dream decoder ring.
According to the scientific perspective, no. The really crucial point they make is that the dreamer, you are the only one who can really figure out what a dream might mean to you. It connects to your life, your feelings, your recent experiences.
So it's less about universal symbols and more about personal context. What's going on with me?
Exactly. The dream content might be your brain working through your stuff, processing your day, not sending you a coded message from the universe using generic symbols. It shifts interpretation from looking outward to looking inward.
That's a really important shift. Self-reflection, not symbol lookup.
Okay.
But dreams aren't just about processing the mundane, right? They're linked to creativity, too.
Oh, absolutely. That link is pretty strong. You hear the stories Mary Shelley dreaming the core idea for Frankenstein, Mendeleev supposedly seeing the periodic table in a dream, Salvador Dali using dream imagery all the time.
Why would that happen? Is it that less inhibited REM state?
That's the idea. During REM, your brain might be making looser connections between different memories and concepts, things that wouldn't normally seem related. That can lead to novel ideas, those aha moments.
And there's actual research on this.
Yes. There was a study using something called the Remote Associates task. It measures creative problem solving. They give you 3 unrelated words, like cottage, Swiss, cake, and you have to find the word that links them.
Okay. Cheese.
Exactly. And they found that people who took a nap that included REM sleep were significantly better at solving these types of problems afterwards compared to people who stayed awake or only had NREM sleep.
That is fascinating. It really backs up the old advice to sleep on it when you're stuck on a problem.
It really does seem to be literal advice. Other studies have cued people to think about puzzles while sleeping, and they showed improved solutions later. If your brain is already processing and linking information, it makes sense it might find new pathways while you rest.
Amazing. Okay, speaking of pushing the boundaries, lucid dreaming. What's the deal there?
Lucid dreaming is basically becoming aware that you're dreaming while you're still in the dream.
You know it's a dream.
Yes. And for some people, that awareness comes with a degree of control. They can influence the dream narrative, fly intentionally, change the scene. It's pretty wild and actually more common than people might think. Many people have experienced it at least once.
Does the brain change during a lucid dream?
It seems so. Studies using brain imaging show increased activity in areas like the prefrontal cortex during lucid dreams compared to regular REM sleep. That part of the brain associated with self-awareness and executive function seems to wake up within the dream.
Which makes sense if you're suddenly self-aware. Are there ways people try to, induce lucid dreams?
Yeah, there are techniques people practice. Things like reality testing, asking yourself, am I dreaming? Throughout the day, hoping the habit carries over. Mild mnemonic induction of lucid dreams, which involves setting the intention before sleep. And WBTB, wake back to bed, where you wake up for a short period, then go back to sleep, aiming to enter REM more consciously.
Interesting. Okay, hold on, because this next bit from the research is where my jaw kind of dropped.
Oh.
Actual communication with people while they're dreaming.
Yes. This is that National Science Foundation-supported research. It's truly groundbreaking. You know, the huge challenge in dream research has always been getting information in real time. You usually just get fuzzy reports afterward.
Right, the dream's over by then.
Exactly. But these researchers found a way. They worked with lucid dreamers, people aware they were dreaming, and established two-way communication using eye movements. Since the eyes can move during paralysis, they trained participants to use specific left-right signals.
So someone inside a dream is using their eye movements to talk to researchers outside the dream.
Correct. Real-time, verified communication. They gave an example. They asked a sleeping lucid dreamer a simple math problem, like, what's 8 minus 6? And the dreamer signaled back the answer 2 using the agreed-upon eye movements.
8 minus 6. Signal from inside a dream. That is absolutely mind-bending. It's like sending a message from another dimension.
It really feels like it. The potential implications are just huge. Imagine conducting experiments during sleep, maybe helping people practice skills. One source mentions surgeons practicing or solving problems collaboratively with the dreaming mind, understanding consciousness better. They even talked about maybe using a smartphone app for this someday.
Wow. The idea that this private internal world could actually be interactive,
Yeah.
that changes things.
It really underscores how much more there is to learn about what happens when we sleep.
Definitely. But okay, let's come back down to earth for a second. Despite all this incredible stuff happening, most of us wake up and the dream is gone instantly. Why is it so hard to remember them?
The vanishing dream. Super common. There are a few reasons. One big one is the rapid shift in brain chemistry when you wake up. Levels of neurotransmitters like norepinephrine shoot up to make you alert, and this chemical shift can basically interfere with storing or accessing those fragile dream memories.
So waking up itself can erase the dream.
It can make it much harder to hold on to, yeah. Timing is also key. You're much more likely to remember a dream if you wake up directly from REM sleep or very shortly after. If you transition into another sleep stage, the memory often fades, and honestly, lack of effort. If you don't try to recall it immediately, it just drifts away like any passing thought.
And I guess a blaring alarm clock doesn't help with that gentle recall process.
Probably not.
Yeah.
Being jolted awake, especially from deep sleep, spikes stress hormones like cortisol and immediately snaps your focus to the waking world, pulling you away from that dream state. Waking up naturally seems to be better for remembering.
So if you actually want to remember more dreams, what can you do?
The most consistent advice is pretty straightforward. First, try to wake up slowly, naturally if possible. Second, keep a notebook or journal right by your bed. The instant you wake up, before moving or thinking about anything else, jot down anything you remember. Even fragments, feelings, images, anything.
Just grab onto whatever threads you can.
Yeah, exactly. And third, make a conscious effort. Treat it like any memory skill. The more you practice trying to recall, the better you might get. Setting the intention before sleep can help too.
Though, the sources did mention, right, that remembering dreams all the time might not always be great. It could mean your sleep is fragmented.
That's a fair point. Waking up briefly after REM is normal and helps recall. But if you're waking up constantly throughout the night and feel unrested, that's different. You don't want poor sleep just for dream recall.
Good distinction. But for the dreams you do catch, paying attention seems worthwhile, even without a universal decoder ring.
I think so, and the sources suggest this too. Even if there's no secret message, noticing patterns in your dreams, recurring themes, strong emotions, bizarre scenarios can give you clues about what your mind is chewing on, what you're preoccupied with, what emotions you're processing. It's a form of self-reflection.
Okay, so let's try and wrap this all up. We've gone from the basic mechanics of sleep stages and brain chemistry
To the different theories about why we dream memory, emotions, threat practice, making sense of noise.
We tackled that big listener question about dream meaning, landing on personal reflection rather than universal symbols based on the sources.
And then explored the really amazing potential for creativity, problem solving, and even that mind-blowing two-way communication during lucid dreams.
It's clear that dreams, while still pretty enigmatic, are this incredibly complex and functional part of our brain's operation.
Definitely multifunctional. Whether you remember them or not, whether you analyze them or not, your brain is doing some really fascinating, important work every night in that state.
So maybe the final thought to leave you with is this. Considering how active your brain is during sleep processing memories, working through emotions, maybe even simulating challenges or sparking creative links, and, as we just heard, potentially capable of interaction, what incredible things might your dream life be quietly doing for your waking self, pushing the edges of your own mind completely behind the scenes.
And that wraps up today's episode of Everyday Explained. We love making sense of the world around you 5 days a week. If you enjoyed today's deep dive, consider subscribing so you don't miss out on our next discovery. I'm Chris, and I'll catch you in the next one.